Mr. Nelvell here to help you go over the exit ticket question. As you already read, this question is asking us that Mr. Nelvell, me, visited the island of Geometropolis, shown below on this picture. One day, he went to the swimming pool to relax with his friends. Afterwards, they were all hungry, so Mr. Nelvell decided to go to the cafe. Makes sense, they're hungry, they want food. Find the distance from the swimming pool to the cafe. Each unit is 1 mile. Well, if the swimming pool and the cafe were right next to each other or in a straight line, we could find their distance really easily. We could just count on the grid. But here, if we look, here's our swimming pool, but the cafe is up here. If we want to find the distance from the swimming pool to the cafe, we can't just count because it's going diagonally. We saw that last class. So that means what we have to do instead is we have to try to figure out how is x changing, how is y changing, and use that to help us solve for this distance. Now, here I see, oh, well, x is changing. I'm starting here, and I'm going to the right this many units. This bit I'm going to call delta x. You can't really see that. Let me choose something else. Let me get a different color. There we go. This will be better. All right, from here to here, this thing we're going to call delta x. This is our change in x. And going up and down, let me pick another color for this. Going up and down, this is going to be our change in y, delta y. Delta y. So in order to find distance, we want to take our, let's go back to the other color. We want to take our delta x, square it. So we want to see how much is our x changing by, and then we're going to square that. And then we're going to add our delta y squared. And that's going to give us the distance that we want. This distance over here, squared. Now you might be wondering or trying to remember, why is this true? How do we know this? Well, this is just the Pythagorean theorem. Here we see, oh, here's A, here's B, and this side is going to be C, that distance. So we're squaring how much x changes by, we're squaring how much y changes by, and then that's going to equal d squared. I'm going to write a note here. This is the Pythagorean theorem. So, because of the Pythagorean theorem, well, let's find out how much does x change by, how much does y change by. Here I see x starts at -3 and goes to 2. So I count 1, 2, 3, 4, 5 units. So I'm going to have 5 squared. What about y? Y changes from -1, it goes up to 3, so that's 1, 2, 3, 4. It's going to be 4 squared. So 5 squared plus 4 squared is going to equal, and d squared, we still don't know what that distance is, and so that's still going to be d squared. All right, 5 squared, we know what that is. 5 squared is 25. 4 squared is 16. And again, we still don't know what d squared is, so that's going to stay the same. Let me put in these pieces. All right, so 25 plus 16, we can add that together. That's going to give us 41. And 41 will equal d squared. But in order to find the distance, we don't want d squared. We want to make sure we square root both sides. And so we're going to end up getting the square root of 41 miles is our distance. That would be the distance if we went straight from the swimming pool straight to the cafe. Now, Mr. Nelvell's probably driving a little bit more than square root of 41 miles because the road probably doesn't go straight from one place to the other. He's probably going to go around a little bit. Some highway that takes him down like that. But this distance right here, he is square root of 41 miles away, or the square root of 41 we can find, that's going to be 6.40 about. Approximately 6.4 miles.